Hi, in this video we're going to be talking about single replacement reactions. So single replacement reaction is very similar to double replacement, except this time we only have one element replacing the other one. And now only elements which are more reactive can replace the less reactive element. And we're going to define that by looking at this chart. Alright, if we're dealing with halogens, which is type D, we're going to look at this. Everything else we're going to look at this. And if you're going to replace something, see if the element is on top of it. So let's say you have F and you're trying to kick I out. Is F above I? Yes. So the reaction is going to occur. If it is not, then the reaction will simply not occur. So let's do an example. Let's do 3 different examples here. All right. First example, we have sodium chloride plus fluoride. What does that make? So first example, we have NaCl plus F2. Fluoride by itself is F2. Alright, NaCl, fluoride 2 is a gas, a diatomic ion gas. NaCl is chloride, and all chlorides are aqueous. So this is aqueous. Okay, no, all group 1A is aqueous still go. So now, what does that make? So we're gonna kick the halogens, gonna kick halogens, metals gonna kick metals, cations gonna kick cations, etc. Alright, so over here we have a halogen and a halogen. This is type D. Type D. With type D, we're going to look at this chart. So we have, F2. So our lonely F2 is going to want to fit into this compound. All right. So what is going to kick? Cl. And now it has to be Cl2, right? So you're going to have to put a 2 in front of this Na. All right. Now, is F2 going to successfully kick Cl out of its place? Yes. Why? Because F2 is above Cl2. So this will make, instead of NaCl, it's going to become NaF2 plus Cl2. And this will be aqueous, while Cl2 will be gaseous. And now as you can see, basically we're going to have our lonely compound here try to replace the compound that we have and form a new compound and new element. So let's do our second example. And we have aluminum iodide plus magnesium. Aluminum iodide is Al with the 3 plus, so it's going to be I3, aqueous, plus magnesium, Mg, 2 plus. Solid by itself is solid. Alright, now this time we're not dealing with a halogen, we're dealing with 2 metals. So this will be type A. We have metal. Now AB plus A will result in AC plus B. Will that work? Mg is trying to kick the metal out, which is Cl. Can Mg kick Cl? We're gonna look. No, can Mg kick Al? We're gonna look on this chart, and we can see that Mg is above Al, which means A can successfully kick Ai out of this Al, out of this compound. So what do we have here? Mg. Since this has a 2 plus and the other one has a 3 minus, so let's try to balance. Let's try to work it out over here. It's gonna be 3 and I2. Alright, plus Al2. Why? Because now we're gonna add a 3 in front. So there will be, I'm not gonna add a 3 in front. Sorry. Mg has a charge of 2 plus, I had a charge of 1 minus, so it would be MgI2. And to match this, we're going to have to add 3 in front. So this will have a 2 in front, and this Mg will have a 3 in front. Plus the Al2, which we got from here. And that is our final reaction. Let's see, Mg is in group 2A, but iodide, all iodides are aqueous except for silver, lead, and mercury, which is not Mg. So this will be aqueous. And Al2 is a solid by itself, which is a solid. And now this is type A. Alright, our third example, we have aluminum. Oh, a lot of this got deleted, but you know it's aluminum. Third one is aluminum plus sulfuric acid. Aluminum is Al, 3 plus, solid, plus sulfuric acid is H2SO4 aqueous. Alright, let's see. We have an acid, which means it's type C. This will be type C. So what does this make? What do we have here? We need to active metal replaces H. So Al is going to try to replace H. Let's see if we can do that. H2 is down here while Al is up here. So yes, it can replace it. So it's going to be Al 3 plus and SO4 2 minus. I know this is not bonded properly, plus H2. Alright, now H2 by itself is gaseous. Now let's balance this. 3 plus, so this will be for every 2 of this, which makes 6. There can be 3 of this, which also makes 6. Now that is balanced, and now we're gonna add 2 over here, and sorry, a 3 over here. That means the 3 over here would be 3H2. Alright, AlSO4 also fades. All sulfates except for calcium, strontium, barium, mercury, lead, and silver, which is not aluminum. So this would be aqueous. And now these are our examples for single replacement. Basically, the lone element gonna try to replace the compound to form a new compound and a new element. And we're gonna know if that can happen or not by looking at our chart over here. Thank you for watching.